This creates an electrical signal that comes out on these two wires. Essentially, these are magnets here, and we have a metal string that vibrates, that induces an EMF. We have a coil that's wrapped around the magnets, and that EMF that's induced creates current that flows out of these wires, alternating current. And there's three circuit elements to this device. One is it's a long coil of wire. So the longer the coil of wire, the more wrapped the pickup is, the bigger the resistance is because there's more wire. Secondly, any kind of cable or wire that's wrapped like this has an inductance. And so we have inductance. You can see inside there's lots of wires and they're all very close together. And that closeness creates what we call a capacitance as well. So we've got three elements. We've got resistance, we've got capacitance, and we've got inductance. So let's draw that up on a schematic now. So we have the string. Just going to draw this as a vibrating string. If you look closer at a string, it would look like this. We have the inductance. That's a symbol for an inductor. Then we have the resistance. And then we have what runs in parallel with the circuit, the capacitance. This actually then connects to your volume pot on the guitar. So the job of this is to short circuit this back to ground so you don't get any current flow. And then we also have another element usually, which is another pot that goes through a cap, which creates a filter, so all the high frequencies go down to ground depending on where you have this. And then this goes to the outside world, to the jack, and the cable electrically is similar. It has a resistance and it has a capacitance. And the longer the cable is, the bigger this capacitance is. So the longer the cable becomes, the less higher frequencies will pass through the cable, and they will be passed more down to ground and attenuated. And that's one of the reasons why we use a buffer, is to eliminate this effect of a long cable and produce a much brighter tone.